last lecture we have seen how to choose function approximation algorithms and what are the sub steps, how to estimate training values, how to adjust the weights, and then finally we have seen LMS weight update rule, and then learning rate and all, and then rule for estimating training values. Those concepts we have discussed. Today we are going to discuss about the final design. Okay, so the final design. So this is the last point that we must discuss. So the final design of our checkers learning system that we have taken earlier, all these points were discussing based on this checkers learning program. Okay, so checkers learning system that can be naturally described by four distinct program modules that represent the central component in many learning systems. And those modules are, first one is the performance system. The performance system. So the performance system is a module that must solve the given performance task. In this case, playing checkers by using the learn target function, okay, or functions. It takes an instance of new program or new game, you can call it, as input and produces a trace of its solution as output. Okay, in our case, the strategy used by the performance system to select its next move at each step is determined by the learned VCAP evaluation function. Therefore, we expect its performance to improve as this evaluation function becomes increasingly accurate. So the main target is that to make this evaluation function VCAP more and more accurate. Okay, and for that we are using this approximation concept and all. And second point is the critic. So the critic takes an input, the history or the trace of the game, and produces an output, a set of the training examples of the target function. That means choose move function. That means function V. That means the function VCAP. As shown in the diagram. Okay, fine. The third point is the generalizer. So the generalizer takes an input, the training examples, and produces an output, hypothesis, that it is estimate the target function. It generalizes from the specific training examples, hypothesizing a general function that covers these examples and other cases beyond the training examples. In our example, the generalizer corresponds to the LMS algorithm and the output hypothesis is the function VCAP described by the learned weights W0 to W6. Okay, so when we are using this LMS algorithm and the output hypothesis is the function of VCAP described by the learned weights W0, because these weights will be learned, right? How much weight actually has to be given to the different x1 to x6 features, different features, that once it is learned, then the function will be more accurate, it will perform more accurately. And then lastly we have the experiment generator, which takes as input the current hypothesis and outputs a new problem, or that is initial board state, for the performance system to explore. Its role is to pick new practice problems that will maximize the learning rate of the overall systems. So in our example, the experiment generator follows a very simple strategy. It always proposes the same initial game board to begin a new game. Okay, so more sophisticated strategy could involve creating board position design to explore particular region of the state space. So we can have different state space as the complexity of the learning algorithm will increase. That means the V can. So lastly, we are going to summarize the checkers learning program. So first, what we have done, we have seen how to determine the type of training experience. That is the first thing we have done. Okay, So this training experience, for determining this training experience, we the checkers has to play against experts, and then game against self, then table of corrective moves, everything it has to do. So it has different ways you can optimize this, determining this training example, determining the type of training experience, different way you can optimize it. So second point is, so this is the first one, and then second is point number two. Second stage is determining the target function. So target function, from board move we can see how target function actually is implemented. And then after target function we have to learn, at point number three, we have to understand how to determine the representation of learned function. So from here to here, learn function. Okay, this is point number three. In learn function we have this polynomial way or linear function of 6 features, and then artificial neural networks, we can do it. Through that we can achieve this. And then fourth one, which is the next step, fourth one is determining the learning algorithm. Okay, it may be linear programming or gradient descent learning algorithm. And then fifth one is that after doing all these steps, that means step 1 to step 4, the checkers learning program will be completed and the design will be completed. So we can actually say that there are totally 5 steps to describe the summary of the checkers learning program. I hope you have I hope in last couple of videos you have understood how to design a learning systems. Okay, so thanks for watching.